cloud and one server on premise. Yeah, on premise. And your selection from row, selection from row defines the location of each activity and the associated data. It's based on posts, monetary posts, performance, and data restrictions that will define the where one can't be allocated in the cloud.
You have some algorithm to
Yeah. We develop an approach and implement it.
Okay, thank you.
Thank you so much.
You want to use injector? No, I think. Our second paper is Business Process Management with Mobile Routes by Sharif Mahmoudi. Can you introduce yourself first?
So thank you, Chairman, for this presentation. So I'm here to present my work with Fabrice Morin. So it's about rethinking business processes using a mobile approach. So to introduce myself and the general context of this work, so I'm from the AICCSA laboratory of algorithm complexity and logics. I'm a team of parallel communicating system managed by Professor Qatar Dima. Our work group is mobile communication system managed by Fabrice Morin. We are 4 persons in this work group: Cyril Dumont, myself, Guylaine Chicken, and Stephen Antel. We collaborate with some industrial projects like Mobile SIM and Mobile Partner. And we are open to collaborate with more on new projects. So, I would like to present the state of art on service composition. So actually there are two essential approaches used in web service composition. First one is WSCDI, presented the first time by from 2003 by Chris Pence, and the other one is Beeper for WS. It's an extension of Beeper for managing web services. So this is classical approach. There are new, some emerging approaches like EIEEE enterprise integration patterns and introduced by Grigorov and Bobby Wolf. So the first time in 2002, and they wrote a book on 2008. And an integration framework things we will discuss about later. We have contributed to this to manage business processes. There is some references. So before talking about business processes, I would like to introduce the notion of business agents. An agent is simply a piece of software that has 4 properties. First is the autonomy. So an agent is a program that is master of its decision. It's reactive, so they can perceive the change of his own environment. He's proactive, so he determines the action to achieve his objective. And he's social, so he can communicate with other agents or other programs. So we define the notion of business agents. So we define business agents as a composition of business services where autonomy is based on some frameworks like OAGI, and especially Zookeeper, Mesos, and Marathon. The reactivity is based on its integration in an enterprise service bus. Is proactive because it's a business process. So business process determines a workflow that determines the action to achieve his objective, and sociability aspect is based on the orchestration principle. So a business process is used to orchestrate web services. So we use web services because of the analytic concept. So they are allowed to have an independence of concern. They have a design concept based on the pattern business delegates, who where a web service is an application of this design pattern is a task encapsulated into a class. Program class, and you have a programming aspect, so we use frameworks, and we have a life cycle, and we use it to allow a short time to market, or a short deployment time. So business process management is that can mean many things, but we will focus on some of business process aspects. First is reduction of human error by automating the workflow, and try to minimize miscommunication between different actors in the workflow. So we focus stakeholders on the requirements and the business rule. I don't think about technical aspects. And especially when we talk about business process management, we will talk especially on the orchestration aspect. So an orchestration is an entity that manages complex cross-domain business processes. So, talk about orchestration and why we need this orchestration. We need orchestration first for web service coordination. So, we determine a workflow description. We use an orchestration to describe a workflow. So our agent does not know other self-service or the protocol that we'll use to call this self-service. We need orchestration also to do some software transaction. So in a business process or in a workflow, it's implemented by an algorithm based on a composition of some web services. So we want to do this workflow as an atomic transaction. And one of interesting properties is the location. So when we talk about web service, we don't care if the service is local or is a remote service. And orchestration allows us to have some activity monitoring by tracking the business process, and we can monitor and track the impact for cloud services. Sorry. So, an orchestration is defined in W3C glossary as the pattern of interaction that must respect the web service agent to achieve his purpose. So, experts will describe business logic into a main description, maybe as seen in the previous presentation, using BPMN, a graphical notation, or BPMN or using a textual representation, or using some code. And we will focus in this third approach where an orchestration is defined by a code that represents an interpretable representation of business process. Just quickly some examples. So a business process or an orchestration can define the investments manager in a financial organization. We can, business process can express the inscription on a conference, and this can also provide the audit process on stock management into a manufacturing. So there is a little illustration to see what for a process described using Beeper. Generally, there is some notions that turn around the orchestration. So monitoring, dependency management, sequencing, bidirectional communication, distributed control, binding management, and essentially workflow automation. That is the main aims of the orchestration. So when we talk about orchestration, we need a framework to implement this orchestration. It's good to talk about an orchestration and make some diagrams, but we need to have some framework, some code to have an executable, an orchestration that we can execute in an enterprise context. So for that, we decided to use an integration framework, and we choose that because if you have an application, your application are built using different stacks. Maybe we can develop a service using C++, another one using .NET framework, and another one using Java. So if we have a unique language or a unique stack of technology, that may be easier, but concretely in enterprise, it's very rare to have a unique stack. And the integration framework is critical to business integrate. So what is framework? So framework do the heavy, all the heavy lifting. We can focus on business problem and not technical problem, and not reinventing the wheel. There are some frameworks that are available open source, but we have to use it. So there is some example for orchestration engine that support DeepL. So like Apache Ode by GBPM from GBoss or at BPM. There are existing solutions, heavy solution, maybe they cost licenses, maybe license of Oracle cost too much money, but all this is an open source. But we want to rethink the business process management. So we have used Apache Camel in our approach. So I will introduce Apache Camel with a quote from the Apache Camel website. So Apache Camel is a powerful open source integration framework based on non-enterprise integration pattern, a standard that is have been created by Grigor Hope, and we will use this enterprise integration pattern to compose our web services, and then add the mobility aspect to this service. So we introduce on our work the enterprise integration pattern based mobility. So enterprise integration pattern specification was not initially dedicated to compose orchestration, but that could be used solely for orchestration. For example, the transformer and the aggregator pattern that can be used to achieve this goal. So and Apache Camel is based on the pipe and filter architecture that allows to filter and communication between two steps. So there is an example for a representation with communication between two servers. So the idea that we have some messages and we want to filter one of these messages or request. So for example, in English we can say that from server A we filter messages and send them to server B. And Apache Camel offers an intelligent way to express this. So we can just reformat at first time this expression from A filter with a predicate and to server B. For example, we can express this like that, and we have a Camel DSL expression. So this expression that may be like this. For example, if we want to apply this approach to flight reservation, we can declare a next pass expression that filters our message, and then use this XPath expression as predicate to our filter. And maybe we can declare endpoints, declare XPath. Concretely, in Java, it looks like this, with a configure method that we express the entry endpoint that represents server A, the endpoint that represents the target server B, and an XPath expression. We add some import and class declaration, and then it's all that we need to have a very simple orchestration that can communicate with a target server, get response, and send it to another one. So this is just we can use this another way to express this. So in our approach, we have defined a formal representation of this work. So we express our orchestration in a formal way using an extension of pCalculus that we call PDSL. So this is a tool that we have made for this. Is accessible on this URL if someone is interested to use it. So we express our orchestration in pCalculus, in this pCalculus extension, and automatically we generate representation, a Java code associated with a formal definition of an orchestration. So using this code, we have to read it, and then we have a component that we can deploy on the web server, on AICCSA server. Just to note that because of this formal specification, this is a higher level specification. So to generate the code, we have to add some precision and some detail that we can't express in formal language. About our architecture, is based to some framework that are tendance actually. So these frameworks and tools, in addition of Apache Camel that is used to implement concretely the orchestration, we use other frameworks like Apache Mesos, Qatar, and Doha to deploy our application. So here we can see in the top on the right a zookeeper column that allow a high availability. So zookeeper column keep some Mesos sleeping masters, and if the primary master have a problem, shut down, zookeeper quorums switch directly to another master and connect it to slaves. So we talk about development on our business process using Apache Camel. So this is the business process root job. And this business process root job are retrieved by marathon scheduler and sent to the Mesos master. The Mesos master send this route or this business process route to a first slave. And this first slave, this is the location of the first service. So this route deployed on Qatar locally first service, and then it's migrate to the other slave where is located service 2 and call this service locally. And then we have a route migration or a business process migration from one host to another one to call all our services locally. Briefly, our case of study is based on a flight comparator. We can see on the right the description using the enterprise integration pattern notation, and we use an XML payload to attack to send messages to test our case of study. We have some results to call two companies, two reservation company, and on the average we can see the cost of the mobility. So the mobility, it's 2 times with mobility with mobile roads, the car costs 2 times, is two times longer, but it's not expressive. We want to do this to express that the fact that there is a cost to our migration, and in case of there are heavy calls to local service, this cost of migration don't have chance and become incurable. We can accept it if there are heavy communication between service, the business process, and service. To conclude, we have established some business features like flexibility using using different tool framework and declarative deployment target. We try to rethink in business process definition using cluster scheduler, prefix load, and manage to build, package, and deploy our service. Or technical feature using Mesos Marathon Docker architecture to manage cluster management, failure detection, and failover mechanism. In future, we want to manage corrective software transaction and avoid some security management. So that is all, and thank you.
Okay, thank you very much. Question? You have any questions? Now, is there the one that? Yes, please.
Do you consider in your work using some other tools like ESD? Like equal service, web services, using Apache?
Yeah, so actually we deploy, we took a lightweight enterprise service bus to do our work, but we can integrate it with any other enterprise service bus.
Because the ESD is hub of technologies, and it can provide common Apache or DPN or DPEL. So I think it will be more will be easier to work with it.
So we haven't find in classical enterprise service file, we don't find an intelligent way to introduce more mobility. Effectively, enterprise service bus allow many features and we can integrate many technologies, but the mobility aspects is hard to introduce into a heavy enterprise service bus. And in the addition, they support normally they have engine. We can install, for example, Apache Old in self-service mix. It's easy to do, but Apache Old doesn't support our new way to develop enterprise integration pattern. And this is we don't find an easy way to deal with that.
Thank you.
Thank you very much.
Now, next paper presentation for paper ID 205, a framework for mass